Okay, here's a second example of using the universal law of gravitation. In this problem, we're going to ask, what's the difference in the gravitational force felt by a person on the surface of the Earth compared to when that person is orbiting at what we call a geosynchronous orbit, that is out far enough to be overhead all the time if you were looking up. Now that distance is 35,800 miles. That's where all the geosynchronous satellites are. And I'm just going to convert that to kilometers because we need to be working in the metric system. There's 1 mile is 1.609 kilometers or 1609 meters. So to convert to kilometers, we get, let's see, 57,602 kilometers. Now we're going to break this problem down into two pieces and then link them. The first force is the force felt by the person on the surface of the planet, and we'll just call the mass of Earth mass 1, the mass of the object or the person mass 2, and the distance there will be r1 squared, and then the distance at geosynchronous orbit will be r2 squared. Now we can rearrange both of these as I'm doing here, and you'll notice that G and M1 and M2 are the same in both expressions. The masses of the object and the planet haven't changed, and G is a constant. So basically, you could use the transitive property to link F1 R1 squared and F2 R2 squared. So the radii, the distances between the objects change, and so the force will have to change proportionally. And I could now say that the second force, the force far away, is equal to the ratio r1 squared over r2 squared times the first force, and we'll call that just a scaling factor. And that scaling factor is what I want to solve for. That's going to give me the basically the percent of F1 that will be F2. So if I take, and I can just use the units kilometers here because both of these radii will be in kilometers. The first one is 6371 kilometers. The second is the radius of Earth plus the distance away. And so if I square both of those, I get 0.012 or about 1.2%. So the force of gravity at that orbiting distance is only about 1.2% of the force of gravity on Earth.